So I think we're gonna get started. First, I hope you are as energized as I was to come here. This has been truly an amazing meeting. It's so great to see again friends around the world at this meeting and have such productive exchange about our ongoing work and where we want to go next. You know, for me, most of the meeting has reinforced some of the key lessons that time and time again, we realize that the best science that can be done is from this global community working together towards a shared vision. And taking a truly community-driven approach to Atlas building has major challenges. We all recognize it. Grassroots initiative, it is not easy to accomplish, but it's so critical for creating this resource that is scientifically rigorous, will stand the test of time, will be applicable to a broader community, and hopefully spur innovation. And to me, it's been so exciting to see how we're entering a new phase of this atlas. You know, we spent the last many years in building our communities, in developing technologies and different methods, and doing our first pilots, and doing our first individual data sets, and now coming together and trying to figure out how we can all, bring it together to tackle our next big questions. And while we're all working toward what will be our version 1, we know there's so much more work to be done. And while it's both daunting, it is also so exciting. And I'm so delighted to have with me a great panel to kind of tackle some of these questions. And Sarah, it's so great to see you. We can very much see you on the screen. Everyone is saying hi. And so what we're going to first do, I'm going to ask every panelist to briefly introduce yourself, your name, where you're from, and your current affiliations with the HCA. So go ahead first. Yeah.
Do you want me to?
Yes.
I can't see you. Okay.
Oh, Sarah, yes, okay.
Sarah Teichmann, delighted to be joining remotely from Cambridge, England. I'd love to be there, but laid up with COVID. But getting better now. Thank you.
So I'm Mariana Boroni. I'm based in Brazil. I'm head of the Bioinformatics Lab at the Brazilian National Cancer Institute. And I'm delighted to be here. I'm involved in the organization committee this year, and also in several, I forgot the name, but yeah.
Thank you for being here. Aviv.
Oh, I think I turned it off. I'm Aviv Regev. I am based in the San Francisco Bay Area. I work in Genentech, and I moonlight for the HCA.
I'm Chen. I'm based in Cambridge, Massachusetts, I guess, and I'm at the Broad Institute and also at Harvard, and I'm excited to be part of the HCA.
Hi, my name is Maria, and I recently joined EPFL as an assistant professor, and this is my first HCA meeting, and really happy and excited to be here.
And Jay?
Hi, I'm Jay. I'm currently in Singapore, A-Star, Genome Institute of Singapore. And I am one of the OC of HCA, but also leading the HCA Asia efforts together with Sham and Unyang Park. Okay.
Well, we're going to start with an opening questions before opening it to the audience. So I'll invite each member, and Sarah, we'll start with you with our first question. I just mentioned that it's really exciting. We're working towards our version 1 of the Atlas, and there's so much more to do, And so this question is a lot about our next steps. We know that the Human Cell Atlas globally will be a truly important and groundbreaking informational resource, right? But there's a lot to be done next. So in order to create an atlas that is truly generative, both in terms of new research directions and medical questions, what do you think should be our next priorities? What should we be focusing on in terms of next frontiers, the data type to be generated, the methods to be generated, the type of data? Sarah, we'll start with you since you're on the screen.
Okay, thank you. So the way I understand generative, the way I'm understanding it is basically the ability to predict perturbations, let's say, or if you perturb one thing, what's the outcome on another thing? That's the way I'm understanding it. And basically, we have with Human Cell Atlas a huge amount of data, a map, essentially a sort of static map. At the level of individual cells, we do have a lot of states that are essentially kind of small variations or perturbations or large variations on each other. And that, it already comes through, for instance, Chloe, your coordinating, the PBMC sort of blood immune cell atlas integration, and there we have, thousands of samples from individuals in slightly different states, basically in terms of genetics, immune status, environmental status, etc. And that can already, give us a handle on training models that that have a perturbation component to them. In thinking sort of bigger in long term, kind of beyond cells, maybe someday we can do the same kind of thing for tissues, and maybe someday we can do the same kind of thing for a whole human. Like if, for instance, for me, I probably got COVID through my nose or mouth, then how does that perturbation kind of percolate through the whole body, the immune system, headache, etc. So I'll stop there.
We hope you get better very soon, Sarah. We definitely missed you. I'll go to Aviv and then invite everybody else to add to it.
Okay, so maybe riffing off a little bit on the theme Sarah started by taking it a little bit in a different direction. So for the atlas to be truly generative, it needs to generate things you haven't seen before. But the question is, what things would those be? And so I think we have two interesting opportunities there. One is really the multi-scale opportunity. I said that specifically for Gary. He's been such a great host, so we had to. But it's also, I think, one of the more fascinating basic questions in biology always. How does one scale relate to the next scale, and how do things move between those different scales? That's a very deeply biological question. And the atlas gives us this opportunity because, to begin with, we had the ambition of measuring in the different scales, and the algorithms give us this possibility because they give us the possibility of actually relating the scales in such a way that we would be able to generate one from another, measure in one, generate the other. One day maybe measure nothing and only generate. That would be nice. As well as you do that, trying to study that model and interpret it in a way that would explain to us how it happens. And that's where it connects to what Sarah said. So for me, that's one. The second one is, we talk a lot here about diversity and genetic diversity, ancestral diversity, and so on. And that is imperative no matter what. That's actually our moral obligation to the world. We get a lot of resources that honestly come from the public. One way or another, the public pays for us to be able to do these things. And that puts a huge responsibility on us to actually deliver back. So we have to be diverse. But moreover, on top of that, that is actually our path to causality in human biology. It's the ability to actually use the genetic variation between us, the beautiful thing that allows us to do better things in biology, I think, than in any other field. We have this causal starting point. And by having a more diverse atlas, we would be able to build on this genetic variation in order to infer what are the causes of the phenomena that we are observing, of the levels of expression of genes, the organization of the tissue, and all the things that come downstream from that. So I think those are two major efforts. They take a lot of attention. They have a connection between them, but hopefully they also have a big payoff. Goes with next.
Who would like to go next? You don't have to, but we invite you to.
I can go.
Okay, go ahead.
Well, speaking as a person who is interested in cancer, for instance, I think we now have a great data set, a great census of cell states and cell types. Well, I'm kind of going to echo what you have said, because when we are talking about complexity diseases like cancer, it is a multifactorial problem, and we really have to, put all those layers together to kind of understand what's happening and identify the root causes. So I think for, as a future direction, I would like to see how we can really in an effective way, integrate all these multi-layers and kind of connect with the phenotypes, and really in order to, understand mechanistically how cells, they change, how they evolve, and how several diseases they arise.
I guess I'll riff off of what Aviv said, is that I think the multi-scale problem is very interesting, but I think one other aspect is all of our measurements are static. Almost all the time, all of our measurements are static measurements. And maybe we can overcome that by just like sampling a ton of people. Or maybe sampling the same person many times. That's probably very difficult for tissues. But I think that's kind of a challenge. Or maybe we could just generate the time series data. We'll take one measurement.
You just need some ramen in the mix.
Yeah, maybe we just do some non-perturbative imaging. But I think that's an interesting thing, like how do we integrate the temporal dynamics? And maybe it is just collecting a lot of data. I think actually like the cost of data collection is high. And we need to decrease the cost of data collection like 2 orders of magnitude.
But I was serious about the non-invasive imaging.
Yeah, no.
It allows you to measure live. It allows you to measure live people, patients and otherwise, healthy people too. And people are doing it now. It's not actually hypothetical. And I don't just mean people who work with the dishes and the cells in the lab, like us. But for example, there was a beautiful study in Nature Medicine recently where people applied in the OR. And they predict for me the genetic status of tumors. It was, I think, in glioblastoma or another brain tumor. And they direct the care live for the surgeon, whether the surgeon will go for broader margins or not, while the skull is still open. It's actually pretty mind-blowing. You look at that, you can imagine the future.
Yeah. Yeah, and I just want to highlight the temporal dynamic. Like
and that's what gives you the temporal dimension, because if you can do it live, you can measure it over time.
Yeah.
You're no longer destroying the system.
Exactly.
So I can maybe answer this question more from the machine learning perspective. As a machine learning researcher, I think, we recently seen this surge of methods being developed in natural language processing, this like large foundation model, and I think it's really nice to think about like what does foundation model means for biology and how can we kind of generate, and I think it's very different. Biology is very different than NLP, and really to understand the language of cells and like really to use these methods to be able to discover new biology, I think we need a lot of thinking basically which data we want to generate to put into these models, and kind of can we in advance think about the data generation process so that these models can really go beyond just kind of generalizing to scene scenarios and like to scene data sets. And in that sense, I think we also maybe need to think about like what is the proper training procedure for these methods, because biology is very different than NLP, and I don't think these ideas kind of directly translate from NLP to biology.
Well, I think I agree with everyone. Just one thing that hasn't been raised to expand on the topic of diversity. So I think being able to expand more to diversity could mean also equity and being able to bring the technology more accessible to parts of the world that will enable them to generate their own data. And we talked about cost, and I think being able to scale up in a very cost-friendly manner, and already you can generate millions of single cells. Hopefully the sequencing cost is also going down. So this divergence of high-capacity single-cell profiling and low cost will further increase to more, and then the next limiting step will be computational and access to server and so on. And again, these are still very challenging in many parts of the world. So when we talk about diversity, how to make these technologies more accessible, equitable, and hopefully that will in turn help the whole community in Human Cell Atlas.
Thank you, Jay. I'll ask another question and then we'll open it up. There are several ongoing, exciting Atlas projects around the world. I'd love to hear how you think what distinguishes the HCA from these other projects, and what are the questions that HCA is uniquely positioned to tackle. And I'll start with Aviv. Yeah.
So I think there are several distinguishing features. I'm going to put them in 2 categories. There's kind of distinguishing science, and there's also a distinguishing organizational feature. And I might start actually with the organization. HCA is actually very different than many of the other initiatives that are out there. And as a result of that, many of those initiatives are actually related to HCA, and there's no problem with that. So I'll pick as an example the Brain Initiative, because Eddie is in the front row. Yes, there's a Brain Initiative. They are actually the people building the Brain Atlas. But Eddie's also here. And he leads our brain, together with Chen, who's also in the Brain Initiative, the bionetwork for the brain. That's fantastic, because it allows this whole community that looks across the whole human body, we'll get to that when we'll get to the science, to also engage with the Brain Initiative. The Brain Initiative learns something from us, we learn something from them, and we don't actually make the distinction of us versus them, because it's honestly the same people. There aren't many people who are actually different in this, but the context shifts with the focus here and this there. This principle applies again and again and again. There's many, many initiatives out there. The NIH funds a great atlas project called the HubMap, which also looks at the human body. It's not a competitor, it's not parallel. It's like, we're a very generalized umbrella. Everyone is welcome in this tent. You don't have to be funded in a certain way. You don't have to have funding at all, by the way. You can do whatever you want. You can be in high school as far as we're concerned. If you're interested in this work and you want to contribute, you show up. And you can be funded one way or a different way. You can be in an academic research institute. You can be in a company. We have people from both. You can be anywhere as long as you're willing to adhere to the values and work towards the atlas. And that's different. That's organizationally different. It's in no way in competition with anyone else for that reason. Everyone is welcome. And we're happy to talk to anyone, participate with anyone, and so on. That's the organizational side. On the scientific side, I think we do have some distinguishing characteristics. A lot of the atlas projects out there, they have a particular lens of focus, and we have our own. Our lens is the healthy body in order to make a reference. That's our goal. We set up our mission in 2016. So far, the statement still holds, although we're going to consider a revision at the end of this meeting. I'm joking. But the statement holds. It's general, but it's also quite specific. For example, we don't collect disease atlases. It doesn't mean that we don't use disease tissues. For example, the immune people will tell you they can't get all their immune cells unless they actually use disease tissues. But our goal is not to characterize any particular disease. However, there's the Human Tumor Atlas Network, one example of multiples focused on cancer. And that's great, because we're a very broad tent and anyone can participate. But our goal is the healthy reference. And at the same time, we didn't limit ourselves to any particular organ. We didn't limit ourselves to any particular slice through the healthy reference. That scope, I think, is quite unique in the Human Cell Atlas. But it's okay if somebody else looks at that problem too, because we're a very broad organization and everyone is welcome.
Thank you, Aviv. Any other thoughts to add before we open questions? Or any other thoughts you wanted to add? Aviv, you summarized it so well.
I think it's a great summary. Yeah. I mean, Human Cell Atlas, basically, it's in the name. You know, it's a molecular atlas of the cells in the human body, and basically that encompasses, initiatives from whatever funder, whether it's the NIH Brain Initiative, the CZI, the EU, the Wellcome, the Swedish Wallenberg Foundation, whatever. It's a broad church, and it's that's what makes us so special, and it's so delightful to be working, globally with people from so many different countries on, this incredible effort, basically, in this landmark project.
And I would add to that, that's why we end up with these huge acknowledgements with endless funders. So for example, CZI have been a huge supporter of this kind of effort. Now, they support HCA, but they don't actually give money to HCA, as a thing, except for recently when they started supporting our executive office, the people who actually organize all of these activities. But that's actually relatively recent. The vast majority of support has gone to individual groups doing individual projects. For example, there's the seed networks. There were computational methods grants. There were many, many programs like that over time. Where is Jonah when you actually need him to tell you all of the programs? And that's okay. That's actually great. They also have meetings that only their grantees get together and discuss stuff. That's also perfectly fine. This is kind of the overarching place where everyone can meet, where everyone can discuss, where all the problems get worked out, and then everyone continues in their many parallel efforts. Yeah, it's not a traditional model, but it kind of seems to be working, so.
Yeah, it's a very welcoming community. This is how to summarize it. I have more questions for them, but this is your unique opportunity to ask them questions. Going once, going twice. Do I have a hand? I have a hand in front.
Hi, my name's Jasmine Plummer. And so I just wanted to pull on that thread, Aviv, in the sense that I love the idea that we're all welcoming and you don't have to be funded. But the reality is most of the work is being done, as you said, by individual PIs like ourselves that have money. And so if we really want to kind of, even in the Asia, I think the Asian network has done a beautiful job in this, and I'm lucky enough to be part of a CZI funded effort, but if we really want to go globally, and we know where most of the money lives, how do we really do that as an effort in terms of, because most of the work has to be funded, right? How do we do that in a very concerted effort kind of for the next stage of the Human Cell Atlas?
It's a great question. I'll answer it at two levels, and maybe Sarah wants to chime in on that one as well. The first one is we constantly work with the funders. We have various forums with them. Our organizing committee meets together with them. We have a joint coordination committee. They have a forum which is just for funders, where we make an effort to highlight these kinds of questions and challenges. Now, in the end, they choose to do what they choose to do, but we do see these things pay off then in real time, in the sense that we all of a sudden see an RFA and we say, yeah, that's something that came out of being in meetings like these, hearing questions like these, having other kinds of conversations that actually make the funding in the end happen. Now, that was kind of an organizing principle for HCA from day one, from when we had that first meeting with 93 participants in a Wellcome Trust. We had no money then at all. I mean, people paid their own way to come. Wellcome gave the room and food, and it was very nice and generous and amazing, and they helped us organize. But the reality was there was no funding at the time. And instead of waiting for it, we said, let's figure out the science. The funding follows, and we still follow this approach. So that's in the general sense been a principle for a long time. The second aspect is that this particular topic of diversity across the world and of the importance of having funding across the world is front and center in our business plan and plans for the coming years, and we've been working diligently at it because we consider that to be materially important. It was actually materially important for HCA from the start. We had started our equity efforts. Musa, who's sitting right next to you, can attest to that in the first meeting that we had. This is not an afterthought, but it is an easier climate for it now than it was in 2016. There has actually been a palpable change for which I think we are all delighted, and we're going to continue going at it until we address the challenge.
Can I quickly add to that?
Go for it.
I think as what we learned from the experience is that we really have to find good leadership within these countries that can talk to local funders. Because in the end, I agree there are great CCI philanthropic foundations, but they cannot support everyone. So I think key aspect is training and workshops to enable these scientists to be able to practice and talk to the funders and create that community to reach out. And that's one of the efforts as equity and also in HCA Asia. So I think we should promote that.
Can I also add a quick? Also, when we are thinking about training in places like Brazil or Latin America, we tend to prioritize techniques that don't rely on very expensive equipment, so then we can give opportunities for other people also to generate data, not only analyze data that people has generated so far.
And I think before we take a question, I think Sarah, you wanted to add?
Yeah, so thanks, Chloe. Thanks for letting me chime in. So Jasmine is right that the data generation, requires money, and the bigger it is, the more money it requires, and so on. And we've made a big effort to basically advocate with funders around the world, kind of as Jay said, A, and B, also that funders who are able to fund globally, have that global reach. And furthermore, during the pandemic, we also, with Black Lives Matter and so on, our community basically pledged to also advocate for the funders to specifically dedicate, fractions of every award. It was 10 or 20%, I can't remember, but it was fractions of every award towards sample diversity, and as much as possible, also scientific diversity across the world, engagement of scientists from across the world. So that's worth mentioning. The other thing that's worth mentioning is what takes much less money is integration and analysis. It also costs money and time is money and so on. But let's not forget that that's a key part of the HCA community and a key part of HCA, and it's going to gain, if anything, it's going to gain even further in importance. And both the community, analyzing, integrating, interpreting data, and so on and so forth, and also creating the portals, the visualization tools, and so on. That's a component that possibly is sort of more easy to globalize potentially, and furthermore will also have a more global impact. In the sense that making the data openly accessible kind of democratizes it and makes the HCA data and insights sort of accessible globally. So I'll stop there with those thoughts.
Thank you, well, thank you, Sarah. We'll take one more question from Sham and then quick answer from Sham so that we can conclude our panel on time with my last fun question. So Sham, go ahead.
I was just going to continue on the excellent point Jasmine raised. Looking at Kian Hong, who's here, has quantified some level diversity of the data sets currently in the HCA, in the data portal. And we can really point to, okay, these data sets that are not from the traditionally represented groups came from this funding initiative between this funder and the HCA that was agreed. So there's a concrete outcome, right, of funding being necessary to diversify the atlas, and I'm really happy to hear what Sarah said about expanding that initiative. But funding, and that's important, and that's a conversation we have to have with the funders. It's not really the ultimate responsibility of people sitting on that stage, but for them to help us access the funders. But the second thing, sorry, just quickly.
I just beg to differ. I do think it's also our responsibility. We should all be talking to the funders about this.
I was being kind to all of you. The other things you need also are infrastructure and training. So there, I want to highlight the work that Musa and Alex and Partha have been doing on training. That's also key to access the funding and to use the funding. And the third is infrastructure, and that's really working with partially at least working with the commercial vendors to make things more accessible. So we need to work on all three.
Okay, so we have 2 minutes to go, and we're talking about funding. So I guess my question is appropriate. If you could create $1 million grant tomorrow, you're responsible for it. What would be the questions you would ask to incentivize researchers to answer big unanswered questions for $1 million? $1 million is not that big, but it's big, but not that big. The grand scope of things. Short answer. It cannot be a long justification. Faye is ready. Go ahead, Faye. I feel like you're ready.
Okay. Well, going back to the dynamics, I'm fascinated by all these recent observations of lifetime viral exposure in correlation to just disease in other states. And I think the atlas could be uniquely suited to really mine that data. And maybe related to that, maybe not lifetime viral exposure, but somatic variation in people as they throughout life.
Okay. So you're going with data generation. Okay. $1 million for that. Who's next?
Well, you could mine the data that's already in the atlas.
That too. Who wants to go next? $1 million. Out of my pocket. What do you want to do with it?
I guess I get it.
I'm trying to politely wait.
Go ahead.
Well, I was told that I should be funny, so
You don't need to be funny. You don't need to be funny.
maybe I would investigate the cellular basis of hungry, being, angry because you are hungry. So
Oh, that is actually really
that
good.
would help
yeah.
with my kids a great deal.
with
everyone's kids a great deal.
Exactly.
And some adults too.
I would be a good test subject. Okay, yeah, definitely on board for
Maybe
that.
quickly, I think technology is evolving really quickly, and I think one that's happening is single-cell proteomics or, multi-TOF. We haven't really talked about proteins at all, but, human cell atlas, I think there's an aspect of post-translation modifications to metabolome and lipidome, and how that fits into the whole human cell atlas has really been untapped.
Absolutely.
And it's going to happen soon, so $1 million.
Yeah, absolutely. Mariana, any thoughts?
So I would say, I think, in a sense of this kind of generalist AI models, like can we really build something that doesn't require any fine-tuning, anything, kind of like really kind of can generalize, you kind of write the task and that kind of can solve your task, like same thing we have in NLP kind of. So I think it would be interesting actually to think really like what type of, I think kind of what, not only kind of what type of data, but also kind of what type of tasks can we solve in this type, in this framework, and also generally coming up, I think, as a community, like more realistic, really coming up with proper evaluation metrics, coming up with proper like benchmark data sets, because currently in single-cell genomics, there are kind of various computational tasks that we are trying to solve, but I think we lack kind of really proper benchmark data sets, proper evaluation metrics, so everyone is kind of benchmarking their methods on like a different set of data sets. So I think we really need kind of proper guidelines for people who use these tools, how to use them, and like which tools are like the most useful for the task you have.
I think we need even more than 1 million for that, but that's very important. Sarah, I'll go to you and to Aviv. Sarah, go ahead. Any thoughts?
So my group members are very excited about phase method, and I'm not sure how far $1 million will go, but basically applying that to like hundreds of tissues from across the human body would be amazing.
There you go.
Maybe more than 1 million, but. And it may address that brain-gut, axis question.
Oh yeah, hunger and angry.
Yeah, the endocrinology. Yeah.
And Aviv.
So I was not originally going to say this. First of all, $1 million means computational. It's just not enough for all these things.
Do you want 100?
No, it's fine. I'm good. I don't know how many people know that one of the first talks about HCA was when the NIH had these challenge talks for $50 million. So I was like, they don't offer it to you. You just are supposed to suggest crazy things that one could do for 50 million. So that's how we suggested HCA. But in any case, that was a long time ago. I would actually go for the live imaging. I think that's an algorithmic opportunity. I think the technology is there. And I think it would take us the last mile, which is really important. So I wasn't going to say that, but after all this side conversation, I got really excited about it.
Right, we covered the full breadth of possibility, which is really exciting, and I think it's also a reflection of our community and so many challenges to tackle ahead, and we're very lucky to have such a global reach. And so please join me to thank our panelists for a great discussion. Please stay put for some concluding remarks.
And just switch to me when you decide to switch.
Do you want to do any slides? Because I could do all of them. Do you want to do them? Okay. Do you want to? We'll switch to the. Switch to the end. Okay. Go for it. Great. We just wanted to take a few minutes more of time today to cover some closing remarks. So we have some slides that were prepared by Anya Hopalaska, thank you, including a brilliant movie kind of summarizing all of the networking and fun that we had over the past 2.5 days. And maybe we'll post this later. So just you might see yourself in some of these photos that we took. And there we all are. So we also had an amazing virtual component of the meeting, somewhat represented by a bunch of activity on social media here, but all of the virtual people that are listening, we heard a lot of feedback and questions in various different sessions, and that was great. And we had a great venue. This is the day that, the time that HCA went to Mars. And maybe it was a little bit natural because, the logos are pretty similar, so.
It was all meant to be.
So more seriously, we had amazing representation globally from 54 countries, almost 260 in-person attendees, over 1,000 virtual attendees. This is the biggest HCA meeting ever, as far as I understand. Great set of posters, speakers and panelists, and talks and breakout sessions. Thank you very much to all of the contributors for the content, inspiring ideas that were communicated. I heard a lot of feedback that this was, inspired a lot of people to think about the next generation that we'll hear about hopefully next year. So thank you all for a great meeting. We have a few more points to make. We want to hear from you. There'll be a survey coming out. Please fill it out. We really take these feedback seriously to improve the meetings from year to year. So you'll get that in your email. The recordings are available on the virtual platform. You can go to the virtual platform link and see all the recordings of all the sessions, including the parallel sessions that you missed if you only went to one of them. This meeting would not be possible without a big team. I think we're really lucky to have everything really working well, but that was no accident. That was because of funders. So we wanted to thank foundational level support from the Helmsley Charitable Trust, including, we also had gold, silver, and bronze level support from University Health Network, Medicine by Design, and the Princess Margaret Genomics Center at University of Toronto, or in Toronto, CFAR, Company of Biologists, the McLaughlin Center and Sick Kids, and the Ontario Institute for Cancer Research, and general operational support to fund a lot of the staff that put this together, from the Chen Zuckerberg Initiative, the Klarman Family Foundation, and the Wellcome Trust. Do you want to take over?
I'll do the thank yous.
Okay.
That's the only reason I actually stood here. Because he can't thank himself. But we should all, first of all, thank Gary. This has been one of the most spectacular HCA meetings we've been to. It had a fantastic venue, excellent food, and it was all healthy too. Great setup, a really inspiring program. I mean, the opening talk was so-so, but everything else was inspiring. And it was done in half the time. Really, we had to flip because of a mishap. Those happen. Gary just stepped up. He volunteered himself. Who volunteers themselves for those kinds of things? And then he just led it through in this very Gary way, and you can see the product. So really, again, we should all thank Gary. And then there was a program committee. Sarah and I were on it. Mariana, Shin, and Dana worked incredibly hard to figure out the program. Maybe we'll just do it in half the time every year, because it kind of works out. They're gonna not like me for that, so we're super grateful for them as well. And then we had a lot of people live in the meeting and throughout that really helped make this happen. So we had a lot of scribes and mic runners: Maria, Shamini, Eric, Ido, Delaram, Jenny, Mershad, Chaitra, and Roland all ran around and did a lot of stuff, and also took a lot of notes, which allow us to then really pick up on all of these conversations that were happening in the room. It's not just what happens when you're here. We carry it forward later on. And then we had a wonderful staff from Mars, including a fantastic AV team. We have all been in a lot of meetings. This was unbelievable on the AV side. Ellen, Steve, Grayson, Trish, Hilder, Adrian, Jimmy, Brent, Matt, LJ, and Steve. And then a great catering team, Laura, Daniel, and all of them at the Daniel catering team. As I said, the food was both delicious and very healthy. You don't get that often. And finally, to Anna Corpus from the University of Toronto. So let's give them all a big round of applause. And then HCA is an executive office. Those are those people who actually make HCA run. It's a very lean team. Some of them are volunteers. Some of them are people who do this day in and day out as their day job. It's a ton of work. And it's not just the general meeting. It's all these bio networks and coordinating them. It's running, a publication bundle, so we actually have a publication bundle. It's coordinating with the data coordination platform, with the people who do the annotations, with the great folks at CZI, with Lattice and Cell by Gene, with people in multiple institutions, with all of those funders, and telling the funders that they should fund globally in many places around the world, and doing many, many, many other things, figuring out roadmaps, figuring out integrations. All of those things are done by the executive office, but definitely the annual meeting is one big heavy lift. And so Aya, Yoshi, Tracy, Esther, Bridget, John, Lucia, Christine, Ellen, and Samantha, on behalf of both Sarah and myself, and on everyone who's here, and all these 1,112 people online, thank you very much. And then finally, some upcoming events. So first of all, you can go online, humancellatlas.org events, and see everything about events at any moment in time. The Computational Experimental Design Workshop for Latin America, unfortunately, is full. You can no longer fit anyone there, but we're excited about it. And an Asia meeting is coming up in November, and thank you, Partha, for hosting us in Calcutta, India. The registration is going to open on July 17th, and will close for in-person participation in October. Very exciting. I think it's our first Asia meeting in India, if I'm correct. We've been touring different areas. Now, as we said, this is a big tent. It's open to everyone, and anyone can contribute to the Human Cell Atlas, and you can always go and register and be a member if you're not one of the 3,009 members already. The networks, you can join any of the 18 biological networks so that your voice is there, so that your data is there, so that you actually participate in all of these plannings and activities and the science that makes for integrated atlases in humancellatlas.org biological networks. You can always visit our website. You can use our new mission statement, everything, everywhere, all at once. We're going to have a lot of work to do in the coming years. It's going to be super exciting and interesting. And it's kind of nice that in the end we'll get a reference map of the human body. And so, a few key takeaways from the meeting. So many possibilities. How do we prioritize them as we think beyond the first version of the Atlas? This is not a question that anyone in the executive office or Sarah and I are going to show up with a recipe. Anything that happens in HCA happens by the people who are here. Doesn't happen by anyone else. There's no one else. Don't look right or left and expect somebody else to come up with the answer for this. This is on you. What types of new computational methods are required in order to build, annotate, and query the Atlas? And how can we get to those desired foundational models that we might not have to fine-tune for $1 million every time you want a model? So that's on you, Maria, I guess, now. The human has many dimensions. That N is a pretty big N. How many axes of space, time, and human variability do you really need to include? And what is the real dimensionality of the problem relative to the nominal one? The nominal one is huge, right, if you just naively count all these dimensions. But as we know, biology is very structured. Many of these things are actually dependent on each other. What's the real dimensionality? That's what we're figuring out by doing this project. And as we do it better and better as we go along. And so much for us to do, and figuring it out on a multi-scale. Or Gary will call you out on that. And then Atlas building is all about community. How do we make sure that this community is expanded? How do we make sure that all of our colleagues are equitably empowered to do the work? That it doesn't matter where you are, you can serve humanity by doing this kind of work. And how do you coordinate a community as large as that? I don't know, but you can ask John Randall, because somehow he manages to do that. And then, it was a lot of fun to be here. I think this is a very good photo, but the ones with the hands up, that's funner. Yeah. And so we will see you next year. Usually we announce where, and we're not going to announce this time. We feel that that's a jinx after what happened to us before, but we will announce shortly where you will find the general meeting. I can assure you it won't be in Toronto, but we will miss Toronto very, very much. So one last round of applause to Gary and the team and all of you, and see you next year.